Hey everybody, Jake here coming at you with another live math lesson this week. Happy Monday to everybody. Monday, September 26th at 5 o'clock Pacific time. Do these weekly live streams every Monday night at 5 o'clock Pacific time, 8 o'clock Eastern. So be sure to join us here every Monday night. Just go over some math and, answer any questions you have live. As always with these live streams, if you do have any questions along the way, please feel free to throw them in the live chat. I'd be happy to help address whatever questions I can. If I can't answer them live, I'll do my best to, come back and answer them in a later video. But let's go ahead and start talking about what I have planned for you here today. So I wanted to kind of take a step back. I know mostly on my channel I cover calculus topics. I wanted to kind of take a step back from there because I haven't really covered anything that you would need to know as like a prerequisite to a lot of calculus topics. So I just wanted to take a little bit of time today to talk about a couple of different kind of pre-calculus topics. Hopefully for a lot of my regular viewers, this is just kind of some review, but just wanted to make sure that you did have this knowledge because, obviously if there's something pre-calculus wise that you're not super solid on, that can make it tough to move forward from there. But also hopefully with this, we'll be able to kind of bring in some more people into the Jake's Math Lessons community who maybe are a little bit earlier in their education journey math-wise, and we'll be able to kind of go together from there. So I'm not sure how often I'm going to be doing pre-calculus topics in videos. Maybe not every week, but we'll see. We'll kind of play it by ear, see how it goes. But let's go ahead and jump into it. So I got a couple of things here prepared for you today. We're going to be talking about scatter plots, and then we're also going to be talking about distance, how to find the distance between 2 points, and how to find the midpoint of a line segment created between 2 points. So first we'll just start by talking about scatter plots. So I'm going to demonstrate what a scatter plot is and how to draw one based on this example we have here. So we're going to sketch a scatter plot of the data shown in the table. The table shows the number Y of Walmart stores for each year X from 1996 through 2003. So basically what this problem is telling us is we have the number of stores, which is demonstrated by the variable Y, and then in the year X. So X is the year that we're looking at the data for. So essentially in this table here, we have two columns. We have in the left column, the year that we took the measurement. And then in the right column, we have the number of stores that Walmart had during that year. So essentially to make a scatter plot, all you really have to do is start by sketching essentially your horizontal and your vertical axis. So this is typically your horizontal axis is going to be time, not necessarily always, but that's probably the most common thing that you'll see. And then in your vertical axis, you're going to have whatever the thing is that you're plotting. So in this case, it's number of stores, or Y. So another thing to kind of just point out here, obviously, since we're starting at the year 1996 and going up through 2003, we don't necessarily want to start labeling our x-axis at 0. Also, the number of stores is starting at 3,054, so we don't really want to start our y-axis labeling at 0. So you may see this kind of like zigzaggy axis line. Basically, what that means is you're kind of skipping over some numbers. So essentially what we'll do is we'll start labeling at, I don't know, the number of stores is going to go from 3,054 up to 4,900. So from about 3,000 to 5,000 is probably the range we want to label. So we'll probably just start labeling at 3,000. So this kind of squiggly line just means that we skipped from 0 to 3,000 basically. And the reason you put that is because you can see kind of the scale of this line down to this axis here represents 3,000, but then going up to here, let's say to the top of our y-axis that we've drawn here, we're going to go up 2,000 more. So obviously the scale of this little chunk being 3,000, this big chunk being 2,000 is not equal. So that's why you kind of put that squiggly line. It's basically saying that we're skipping over all these numbers down here that we don't really want to worry about drawing. so that we can kind of zoom in on the part we actually care about, which is from 3,000 to 5,000. So then I'll just split this into kind of some smaller pieces. We'll label it 4,000, 4,500, 3,500, so that kind of the area where all of our data points actually lie is kind of spread out and kind of zoomed in on as much as possible. Okay, so then similarly over here, we're basically just going to label all our years. So we're going to have 1996, 97, 98, 99, 2000, 2001, 2002, 2003. And then we'll just label them. So obviously I've kind of shorthanded these, just written the final 2 digits of the years, but that's okay. Just kind of because we're trying to fit all these in a small space. And then really what a scatter plot is it's basically just graphing on a Cartesian plane, which basically just means a plane where you can imagine basically, obviously I don't have full graph paper drawn here, but you can kind of just imagine this on just squares. So we have all these squares where the edges, the top, the bottom, the right, the left edge of each of these squares or rectangles is created by these different markings that we've made on our axes. So essentially to graph these points now, we're just going to look at an XY pair, which just means go to this number on your x-axis. So we're going to go to, I'll get rid of these lines here. We're going to go to 1996 on our x-axis, which is right here. And then we're going to go to 3054 on our y-axis, which obviously we don't have 3054 labeled here, but it's going to be just above 3000. Let's just say right about here. And then basically what we want to do is draw a vertical line up from 1996 and a horizontal line over from 3054. And wherever those intersect is where we want to draw our point. So we'll just draw our point right there. Let me erase the lines and just put our point right there. So that's one of the points of our scatter plot. Okay. Then to find our next point, we would just go to x equals 1997. So right here, y equals 3406, 3406, which is probably right about here. I'm just kind of estimating, but that's kind of the idea when you have these units which are kind of randomly dispersed within these different intervals. Sometimes getting as close as you can is good enough. So we just kind of go horizontally over from here, vertically up from here, and wherever those would intersect is about where we want to put our point. And then we just keep doing that for each of these XY pairs. So then 1998, 3599 is going to be probably right about here. 1999, 3985, so 1999. 3985 is going to be very close to 4,000, so almost exactly at 4,000. So straight over from there, puts us right about there. 2000, 4189, so 2000 on the x-axis. 4189 over here is probably going to be right about here, so. Okay, and then 2001, 4414, 2001, 4414 is going to be pretty close to 4,500, but not quite. So obviously my scale's not perfect here. I'm trying to do this without the horizontal and vertical grid lines going throughout this. It definitely would be a little bit easier if you had actual graph paper with your actual grid lines going throughout. But I'm just trying to get, as close as I can without having those kind of guiding lines going throughout. 2002 is going to be right here, and then 4688 is going to be a little bit above 4,500, obviously decent amount below 5,000, so below halfway, so probably right about here, and then up from there, so we're going to be right about there. And then 2003, 4906, 2003 is here. 4906 is pretty close to 5,000, not quite there though. So probably right about there. So this is basically what we end up with as a scatter plot. That pretty much is everything that we have to do here. And then, yeah, so that's going to be it. That's going to be our answer for sketching this scatter plot of the number of Walmart stores throughout these different years. Basically, it would just be something like this. Okay, so let's move on to the next problem. I'm not seeing any questions in the live chat. As always, if you do have questions along the way, just throw those in the live chat. Happy to help answer whatever questions I can while we're live here, so you don't have to try and find answers to your questions somewhere else. Might as well just get them answered right now. But let's go ahead and move on to the next section here. So what we're going to do is we're going to plot the points, find the distance between the points, and find the midpoint of the line segment joining the points. So the 2 points we have are 1, 12, and 6, 0. So first step, plotting the points. Now that's going to be very similar to what we just did in our scatter plot example. Basically, we just need to start with an XY axis. Actually, let me scroll down and do this a little bit bigger here. So we have X, we have Y, and basically we just want to start by kind of labeling our axis, just like we did in the scatter plot example. So to do that, we pretty much just kind of draw tick marks on each axis. You can see just kind of looking at these points here, just to kind of get a sense of scale, just looking at these points here, our X coordinates are 1 and 6, and our Y coordinates are 12 and 0. So whenever you have XY coordinates, the X is going to be the first number, the Y is going to be the second number. So our X coordinates are 1 and 6. So really we want our scale to be somewhere between going up to 6, basically. So we can say 1, 2, 3, 4, 5, 6. And then our Y coordinates go from 0 to 12. So we can start at 0. And then we need to go up to 12. So we're going to say, we'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 12. I'm not going to label every single one of these. I'll just label the even ones. But you can label all of them if you'd like. So then to actually plot these points, basically what we need to do is find the X coordinate on our X axis. So our first one is 1. So we're going to find 1 on our X axis. We're going to find 12 on our Y axis, since that's our second number. Remember, the first one's always X, the second one's always Y. Find your first number on your X-axis, your second number on your Y-axis, and then just go straight up from your X-axis. Go straight over from the number you found on your Y-axis, and wherever those two lines intersect is where your point's going to be. So we're going to put a point right there. Okay. And then here we're going to find, again, our first number. I'll do this one in a different color now. Let's go with green. Actually, we'll go with this one. It's bluish teal color. Okay, so you're going to find your first number, your 6, on your x-axis. Your second number, 0, on the y-axis. And basically, you're going to go up and down from 6. So you can kind of imagine this going up, going down. And then you're going to go over from your y-axis number, over from 0. And wherever those intersect is going to be where your point is. So just kind of a little tip. If either of your coordinates are ever 0, like in this case we have 6, 0, your point is always going to be on either this x or this y-axis, depending on which of these numbers is 0. So in this case, since y is 0, our point lies on the x-axis. So it's always going to be opposite. If x was 0, our point would lie on our y-axis. So we have our 2 points here. So we've plotted our 2 points. So that was our first step. Now we need to find the distance between the points. So essentially what we want to do is think about the distance between these 2 points, which would essentially be a straight line going from one point to the other point. That wasn't quite perfect. Let's try that again. There we go. Well, better. Kind of went off course there at the end. There. So we have this straight line. So basically what we're trying to do is measure the distance of this straight line that connects these 2 points. If you are getting some value out of this video so far, do me a favor, smash that like button down below. It's a huge help to my channel so I can keep making more videos like this. And hit that subscribe button while you're down there too. I come out with lots of math tutorials like this. Should help keep you crushing it all term long in calculus, pre-calculus, whatever math you're taking. Just hit that subscribe button and I'll help you out. So really, to do this type of a problem where we're trying to find the distance between these 2 points, really all we need to do is use the distance formula. So there is a very convenient formula to find the distance between 2 points, which is this. The distance between a point x1, y1, so if you have 2 points, x1, y1, and x2, y2, so that really just means one x coordinate, one y coordinate, a second x coordinate, a second y coordinate, which is exactly what we have here, right? You could just think of this as x1, y1, x2, y2, your first point and your second point. The distance between these 2 points is just going to be the square root of, in parentheses, x2 minus x1 squared plus, in parentheses, y2 minus y1 squared. Okay, so essentially, all we have to do is plug in 1 for x1, 12 for y1, 6 for x2, 0 for y2 into this distance formula, and we'll be able to find the distance between these 2 points. So to do that, we're going to get the square root of x2, which is 6, minus x1, which is 1, squared, all squared in parentheses, plus parenthesis y2, which is 0, minus y1, which is 12, all in parentheses squared. So really where this comes from is from Pythagorean theorem, which basically says if we have a right triangle, so you can see this right triangle with these side lengths here, your distance d, well, let me take it a step back for a second. Pythagorean theorem says that if you have a right triangle, the lengths of those 3 sides of your triangle are going to be related by a squared, b squared, or I'm sorry, if we call this side A, I'm sorry, I'm kind of getting ahead of myself here. If we call this side A, this side B, and this side C, they're going to be related by a squared plus b squared equals c squared. So if you solve for c, which is the distance between these 2 points, the length of our hypotenuse of our triangle, you would take the square root of both sides, which would cancel the squared there and give you a square root there. So you'd get square root of a squared plus b squared equals the length of the hypotenuse, which is what a distance between our 2 points is. So essentially, the x1 minus x2 is just a. The y2 minus y1 is b, and if you square them, add them together, and then take the square root, that gives you the side length c. So the reason why this is a and this is b, x1 minus x2 is a, y2 minus y1, actually those would be switched, sorry. X2 minus x1 would be our b length here, y2 minus y1 would be our a length here, is because if you're looking on a 2D number line, which is all this is, if you're just looking at your y-axis or your x-axis, that's just a 2D, which just means a straight line number line. The distance between 2 y coordinates is just the higher one minus the lower one. The distance between 2 x coordinates is just the higher one minus the lower one. So taking the higher one minus the lower one just gives you the distance between those 2 points in one single direction. So anyway, carrying on here with our formula, if we were to kind of keep on simplifying this, we'll start with inside of each parenthesis. So 6 minus 1 is 5. So we have 5 squared plus 0 minus 12 is negative 12. so negative 12 squared. Okay. And then the square root of 5 squared is 25. Negative 12 squared is the same as negative 12 times negative 12. The negatives cancel, and you just get 12 times 12, which is 144. Then 25 plus 144 should be 169. And the square root of 169 is 13. So basically the distance between these 2 points, 112 and 60, should be 13. So that would be the distance between those 2 points. Okay. We do have one more part of our problem to do here. We need to find the midpoint of the line segment joining these points. So essentially, the line segment joining these 2 points is this orange side whose length we just found, the distance between those 2 points. We need to now find where would the midpoint of this line be? Well, just like we were able to find the distance between those 2 points, just simply using a formula, we can also find the midpoint of these 2 points, or the line segment formed by these 2 points, by just simply using a formula. So let me erase this distance stuff here because we already found that. We don't need that anymore. Actually, let me check and make sure we don't have any questions before I get rid of all that. Okay, not seeing any questions. Perfect. So let's go ahead and erase this, and we'll carry on with finding the midpoint. So again, we still have this x2, this x1, y1, x2, y2. It's still the same points, but now what we need to do is find the coordinates of the midpoint that we get from this line segment that connects these 2 points. So again, we're going to basically just use a formula here. The midpoint formula just tells us that the midpoint of x1, y1, x2, y2 is just going to be found by x1 plus x2 over 2 is our x coordinate, and y1 plus y2 over 2 is our y coordinate. So essentially where this formula comes from is the x coordinate is just the average of our x coordinates of our 2 points, and the y coordinate is just the average of the y coordinates of our 2 points. Right? To find the average of 2 numbers, you just add them together and then divide them by 2. So if you add your x coordinates, x1 plus x2, and then divide it by 2, that just gives you the average of your x coordinates. Similarly, if we just add our y coordinates, y1, y2, and then divide them by 2, or divide the result by 2, that's just the average of your y coordinates. So your x coordinates just average of x's, your y coordinate is just average of y's. So basically our midpoint should be x1 plus x2, so 1 plus 6 all over 2. And our y coordinate should just be y1 plus y2, so 12 plus 0 all over 2. Okay, so then just simplifying that, we get 1 plus 6 is 7 over 2, and 12 plus 0 is 12 over 2. Then we could simplify these. 7 halves doesn't really simplify, so we can just leave that as 7 halves. And 12 divided by 2 is 6. So this coordinate right here, that is the midpoint between these 2 coordinates, is 7 halves, which is, I guess you could write it as a decimal if you wanted. So you could either say 7 halves and 6, or if you wanted, you could write it as a decimal and say 3.5 and 6. So that would be the coordinates of this midpoint right here. So that's really it for applying the midpoint formula in order to find the coordinates of that midpoint. So I'm not seeing any questions in the live chat. If you did find this helpful, do me a favor, hit that like button on your way out. It's a huge help to me and my channel, so I can keep doing this. We keep crushing it all term long. But I hope to see you back next week. I do these live streams every Monday night, 5 o'clock Pacific, 8 o'clock Eastern. Hope to see you there. Thanks.